Good morning, students. Welcome back to the Microwave Engineering Laboratory. Today's experiment is scattering parameters of circulator. The name of the experiment is to study the operation of ferrite circulator, hence measure the first one isolation, and second thing is coupling coefficient, and third is S parameters. So you have to perform the three things mainly here. The first one isolation, second thing coupling coefficient, and third is S parameters. So you have to perform the three parts. We'll go for the operators, the required operators to perform this experiment in the laboratory. The first one, microwave source klystron tube. Second one is isolator, frequency meter, variable attenuator, circulator, tunable probe, detector mount, matched termination, and waveguide, stands, CRO, cooling fan, klystron power supply, and VSWR meter, and indicating meters. So these are the required components. By using these components, so you have to perform the experiment in the laboratory. Okay, these are the components used in the microwave test bench. Then go for the block diagram. See the block diagram. So microwave source initially, which is connected to the isolator. Isolator is working like a uniline, which allows microwave energy only in one direction, particular direction. Then that goes to the variable attenuator to frequency meter to circulator, and circulator to matched load, and other side detector mount and CRO. Either CRO or VSWR meter, you can use it. If you go for the VSWR meter, we can find the powers directly. So suppose if you use the CRO in the microwave laboratory, we can find the voltages only. So apply 20 log and voltage value, we can find out the powers. Yeah. You go for the circulator operation here. So let me show the circulator. See, so this is how the circulator look like. So it has port 1, port 2, port 3. So 3 ports. See the diagram here. So port 1, okay, port 2, port 3. So 3 ports. So if you connect port 1 to input side, frequency meter side, port 2 acting be like a output port. Port 2 connected to the detector mount to CRO, and port 3 is connected to a matched termination. So you have to change the preferences in this cyclic manner. Then you have to find out the scattering matrix for the circulator. See here, the scattering matrix for the circulator is S equal to 0, 0, 1, S11, S12, S13, S21, 22, 23, 31, 32, 33. So here S13, S13, okay, S21 and S32. These are the values you have to find out. S13, S21 and S32. Remaining all are 0. Then go for the observations. In the laboratory, particularly, how to find out the input voltage. By using CRO, we can find out this one in terms of voltage only. No? Then beam voltage. This is the voltage you have to apply by using the gun bias knob, and that value should be in between 230 to 240. And repler voltage. By rotating the repler knob, which is incorporated to the klystron power supply, by rotating the repler knob in the anti-clockwise direction, you have to fix the maximum signal strength which appears at the screen on screen CRO. So always you have to maintain the maximum signal strength. So that value is in terms of minus 201 to 203. And beam current, always beam current should not exceed 18 milliamps. You have to maintain those values. Then coming to the tabular form. So here see the input voltage at port 1, output voltage at port 2, output voltage at port 3. So one input and 2 outputs. So I told it has a 3 ports. one port is connected to input side, remaining two ports acting like a outputs. So suppose port 1 is connected to the input, okay, I mean microwave frequency meter side, and output port port 2 acting be like a output port, and that connected to a detector mount side, other one is connected to the master determination. So you have to change the preferences, port 1, port 2, port 3 preferences, and how to find out the values practically. By knowing these values, you have to write on the scattering matrix for the circulator. Just go for the calculations, parameters of the circulator. So this is what the scattering matrix I already told. S equal to 0, 0, S13, S21, 0, 0, 0, S32, and 0. So the coupling coefficient for the circulator C equal to 20 log of V1 by V2, that is in dBs. Isolation I equal to 20 log of V1 by V3 in dBs. And measure the S matrix for the circulator. So S13, that value is V1 to V3, ratio of V1 to V3. And the next S21, V2 to V1, and S32, then V3 to V2. So I mean voltage, V1 in the sense voltage at port 1, V3 means voltage at port 3. So by taking the ratio, we can find out the scattering matrix values. Coming to the Viva questions, the first question is, what is an insertion loss? And second question is, what is a reflection loss? And third, what is the zero property of the S matrix? And fourth one, what is the zero property of the S matrix? And what is the function of input and output matching networks? And what is microwave isolator? Why isolator is actually like a line? Then purpose of the circulator, and give the two examples of two-port junctions. What is RF circulator? And a circulator device can also use an isolator with different, modifications, and how to explain why. Okay. Then 11th question is, practically opposite circulator in a ferrite circulator can be obtained by. Explain this one. Okay, I need the right answer for this question. And the dielectric resonator in the circulator has a single highest order resonant mode. Explain. And 13th question, in a strip line junction circulator, the ferrite material is present in the form of. So what form we use in the circulator? So these are the 13 questions I have raised in this particular experiment. Try to answer these questions. Okay, thank you. Let's move to the laboratory and we'll perform the experiment. We see the experiment practically. Then after knowing the S parameters, then we'll calculate the S matrix. I'll explain those things again in by using board. Okay. Thank you. Thank you so much. Good morning everyone, and today's experiment is circulator, to find out the scattering parameters of circulator. So to perform that experiment, see initially, so procedure as it is, and this is what the test bench required for the circulator operations. So initially you have to switch on the fan and make sure the air floating towards to the klystron tube, because it is a high power generator. Okay. So switch on the klystron power supply. Okay. By rotating the beam voltage knob, make the beam voltage 230 to 240. Then find out the current that should not exceed the 18 milliamps. Then by rotating the Rippler voltage knob, fix the maximum signal strength appears at the CRO. And power supply is connected to the mount, and here mount generate the microwave energy which is passing through the isolator. So the purpose of isolator is, it is acting like a uniline. It allows only the energy in only one direction, that is towards to the variable attenuator. And here there is some it reduces the signal strength. Then attenuator to frequency meter. By rotating the frequency meter, we can set a particular frequency to a microwave energy which is generated by the klystron mount.
because here we are using the X band, and that band value started 8.22 ended to 12.4. In between you have to set a particular frequency to a microwave energy. Then after that energy reaches to the detector mount here. So we can find out the very low frequency microwave signal by using the detector mount, and we can observe those things on CRO screen. Okay, and this is over the step number 1. Step number 2, you have to connect the circulator. And the circulator, see, it has a 3 ports, port number 1, port number 2 and port number 3. However, you did the experiment for the directional coupler as it is, you have to perform for the circulator also. So if you connect the port number 1 to the frequency meter and take the output at port number 2 by using the detector mount, and port number 3 connected to a matched dome region. The same way procedure as it is, just change the preferences, port 1, port 2, port 3 preferences, and take the corresponding S parameters. By taking the S parameters, we can find out the S matrix of the circulator. Okay? See, check it here. See the signal? Okay? Now we have connected the circulator to the port 1 is connected to the frequency meter, and port 2 here it is a port 2. The port 2 is connected to detector mount, means we are taking the output at port 2 by using the detector mount, which is connected to a CRO. And other side, port 3 is connected to the matched dome region. It's completely about the energy. Okay, there is no leakage of the power here. So whatever the energy reaches to the port 3, entire energy goes towards to the port 2, means output port. So for the next step, you have to change the preferences. Just change the port. Yeah, port 2 is connected to the input side. Now port 3 is connected to. Now port 1 is connected to a matched dome region. We are taking the output at port 3. Check it. Signal strength is drastically decreased at port 3. Okay. So this is how you have to perform the experiment and find out the S parameters. Okay. And you have to write the S matrix for the circulator. That S matrix is 0 0 S13 and S21 0 0 and 0 S32 and 0. So this is what the S matrix, and you have to take the power set S13, S21 and S32. So by knowing these values, practically we can find out the S matrix of the circulator. Then after you have to calculate the coupling coefficient for the circulator, that is 20 log of V1 by V2, and isolation I equal to 20 log of V1 by V3. Then yeah, so by performing the coupling coefficient and isolation, so yeah, just write down the practical S matrix and finish the experiment. Thank you so much. Hello students, let's see the calculation part of the circulator. So we have already seen the circulator in the laboratory, but again I am showing you. See, so this is not the circulator, okay, a T circulator. So it has 1, 2, 3 ports, 1, 2 and 3. So a T circulator has a 3 ports. Let me explain the calculation part of the scattering parameters of a circulator. So initially, so observations are, so input voltage, what we have find out in the laboratory, practically that is 10 millivolts. Beam voltage is 240 volts. Rippler voltage is minus 203 volts. and beam current is 80 milliamps. Coming to the tabular form, input voltage, and you have to take the output voltage at two ports. Suppose, so one port is the input side. If you connect the one port to input side, and other two acting be like a output ports. So port 1, port 2 and port 3. So voltage at the input port V1 equal to 12 milliamps, and voltage at port 2 V2 is 8 millivolts, and voltage at port 3 in forward direction, that is 0 volts, and voltage at port 2, that is 12 millivolts, voltage at port 3 in reverse direction, that is 13 millivolts, and voltage at port 1 is 2 millivolts. And third, voltage at port 3, which is 12 millivolts, voltage at port 1 10 millivolts, voltage at port 2 V2 is 0 volts. So these are the values we have find out in the laboratory. By using these values, you have to find out the scattering matrix for the circulator. Yeah, see. So S11 equal to V1 by V1. So 1 1 right. So ratio to 1 to 1. So simply 0, and S12 V2 by V1 equal to 8 by 12.6, and S13 0, S21 0.16, S22 0, S23 1.08, S31 0.8, S32 0, S33 0. So these are the scattering parameters. Let me write here scattering matrix. Yes, practical. S11, S12, S13, because it is a 3-port circulator. No? S21, S22, S23. Okay. S31, S32, S33. Now check the values. What is S11? 0, 0. Fine. What is S22? 0, 0. S33? 0. 0. All diagonal elements are zeros. Okay, let's see S12, S12 0.6, S13, S13 0, S21 0.16, S22 0, S23, S23 1.08. Next, S31 0.8 and S32 0, S33 0. So this is for the required scattering matrix for the circulator. Okay, after find out the scattering matrix, and you have to find out the coupling coefficient as well as isolation. So coupling coefficient at port 1, I have taken the values, all values in voltages no, because of that reason I am using the formula 20 log of V1 to V2. So we know the values V1 and V2. Voltage at port 1 is 12 millivolts. Voltage at port 2 is 8 millivolts. Okay. So substituting those values, the 20 log of V1 by V2, you will get 3.5 dB. Okay, 3.5 dB. The next isolation, 20 log of V1 to V3 and 20 log of 2 by 13, and you will get the values minus 16.2 dB. So this is what the value. So coupling coefficient and isolation. So these are the values we need to find out, and this is how you have to perform the experiment in the laboratory. So initially you have to connect the circulator to a detector mount. Okay, so without circulator find out the power or voltage, and after connecting the circulator with the different combinations and find out the voltage values, and after find outing those values, okay, calculate the S matrix, scattering matrix practically, and those values are 0.6, 0, 0.16, 0, 1.08, 0.8, 0, 0. So this is what the required scattering matrix for the circulator. After find outing the circulator scattering matrix, then find out the coupling coefficient and isolation. Okay, thank you so much.